I've heard so many developers argue over choices that pit performance against domain entity design. And today we're going to look at one of those situations. I'm going to show you a solution, and as always, we're going to measure it in nanoseconds. Today's topic, how to supercharge your Dapper repository. So one of the premises of DDD is that the domain entity should always be in a valid state, and to do that, we need to have some validation or some business rules to protect the entity when a property is getting mutated. And here's an example. We have a customer class, and it has a rule that if a customer is deceased, then orders can't be added to the order collection. So the add orders method is enforcing that business rule, but the reality is, because this is public, there's nothing stopping another piece of code from actually going ahead and altering the orders by adding one or removing one. So that's what we want to change. All right, so let's take a stab at fixing this. First thing we're going to want to do is we're going to make that orders collection a private method or a private field. So we can do private list order, and we'll just do this underscore because it's old habit. All right, so now we've got a private list of orders, which means this property is no longer needed. We do need to expose that collection, so let's just change this to a function. But let's do this as a read-only collection of order, and we can just do. Whoop, there we go. Thank you, IntelliSense. And we can just return this as read-only. All right, so now that's going to protect our collection from being altered by some other piece of code. We just need to go ahead and fix this add order method so it points to the orders collection that's private. All right, that's it. So this will enforce our business rules to protect the collection, but that's where the problem really begins. The repository needs to update that collection with data from SQL, and it's not going to have access because that collection is private. Now, many ORMs will use reflection to perform that task, and I'm going to use that same technique. But before you start complaining about how slow reflection is, remember at the top of the video I said nanoseconds. To demonstrate how we'll implement reflection, I've created a method getCustomers, and this creates a customer and a list of orders that we can assign to the customer. Now, in order to use reflection, I need to get the field info for that field that I want to update. And field info, it's basically all of the metadata about a field in a class. And it has two methods to get and set a value. So in order to get it, what I need to do is I need to specify a type. And in this case, that would be a customer. And I can call getField. And I can give it the name of the field, underscore orders, and include some binding flags that describe the field that I'm getting. Now, orders, that's a bit of a magic string, and that's not awesome, but we could go to the customer class and define a constant that represents the name in the field. In fact, actually, let's do that here. All right, so what I've done here is I've went ahead and added a public constant string for orders field name, and I just used the name of function to get the name of that field. So now what that lets me do is go back to this customer repository, and I can just say customer dot orders field name. So that way, if that field name ever changes, now this will automatically get updated. All right, so now we have our field info. I can go ahead and put this to use. I can say set order items, set value. That's the function that sets the value for reflection. And I can say customer and orders. And that's all I need to do. Now, I think this is a fairly concise syntax, but there are times where you may not want to have all of this property info, this field info definition in your class. So there is an alternative. You see, we could use a static function that takes in an expression and a value and sets a property or a field. And the advantage to this is that the code in the repository would be, well, prettier, but slower. All right, let me demonstrate. We have a customer entity that has a name property, and the setter is protected. So if I'm in the customer repository, I won't be able to say customer.name equals test because it's protected. I'll get a warning there. So one of the things I've done is to actually create a function in the repository base class that'll allow me to do this operation without having to define the property info up at the top of the repository. So I can say set property value, and then I can pass in an expression, and in that expression I'm going to say customer.name. So I'm specifying the property that I want to update, and then I can go ahead and just pass in the string that I would like to set it to. So this is I think this is aesthetically pretty pleasing. We don't have to define the property info for it, which is great, but let's take a look at the ugly underneath. So if we look at the repository or the set property value, you can see we're taking an expression. It's really an action with two parameters, one for the property being updated and one with the new value. Now this expression gets parsed to identify the property info, and then reflections used to actually set the value. So you could actually take the output of this function that identifies what property info is being identified, and you could cache that to try to improve the performance of a function like this. But it's a fair amount of work to do all of the figuring out what the actual property info is from the expression, and that part doesn't get cached. So I don't know that it really pays off the way I would want it to. But the benefit of this type of an operation is that you don't actually have to create those field info and property info definitions up at the top of the repository. So again, it's a trade-off. Time for benchmarks. So I've started using benchmark.net, and I think it's pretty cool. And for something like this, it works great. So here I've got 3 methods that test a public setter, setting with reflection, and setting with an expression. I've actually added a protected collection of orders, so I can go ahead and run this test as well, because the set property value function has to be able to declare the property that's being updated. So let's go ahead and give this a run, and let's see what we come up with. All right, I promised nanoseconds, and I have delivered. Our fastest time comes from set with public. It's a public setter, and that comes in at 2 nanoseconds. That's as fast as it's going to get. We're not going to beat that. Set with reflection, where we define the field info up at the top of the repository, that does really well at 40 nanoseconds. That's a really quick time. Set it with an expression, where we're going ahead and piping in an expression that has to be parsed. That's much slower. That's going to be about 0.1 milliseconds. So, you do pay a penalty for having to do that parsing. But, it's important to look at these times with a perspective of what this is really doing. We're going to have a repository that's going to call out to a database, probably over a network connection, and that's going to take a substantial amount of the time. So, these times measured in nanoseconds might be inconsequential. It kind of depends on what your use case is and how you're going to work with them. So, consider that. I hope this has given you a chance to think about how fast reflection can be and some ways to implement it for your repositories, so you can have aggregates that implement business rules that actually protect that aggregate. Thanks for listening. Talk to you soon.